And in this course, we will try to find, if it exists, we will try to find the analytical solution. If there is no analytical solution, then we can find an alternative numerical solution to it. There are many cases where analytical solutions are not exist or not feasible. For instance, the irrational number of pi. No matter how many digits you use, you will not get the exact solution of it. It is an approximate solution. And in engineering, we can use something like this to replace pi to find the calculation result. And in the other example I gave you earlier, the determinant of a matrix, we can use numerical solution to solve this kind of problem, because in engineering you often get high order matrices, so you cannot rely on analytical solutions. We have to use numerical solutions. And numerical solutions are applied in almost all engineering disciplines. For instance, in mechanics, we have to use partial differential equations, something like this. We have to use finite element method. And in aerospace or automatic control, we have to use a lot linear algebra or other numerical methods for ordinary differential equations. And in all engineering disciplines, we may use many branches of mathematics based on numerical solutions. And I shall talk about this in detail later. So now, let me give you a very brief overview to the mathematical softwares and the development of them. There are a few stages of numerical packages. The first stage will date back to the 1960s. And there are quite a lot of well-known packages. For instance, the LinPack, you can recognize from the name, is for linear algebra, LinPack. And AcePack, it is concentrated on solving problems of eigenvalues of matrices. And apart from this, we have NHE, numerical algorithm group. And also there is a very influential book, and where about 200 packages, 200 functions are contained, reliable functions are contained. So there are quite a lot of packages. And at that time, they are the leading edge computer packages. However, if we talk today, we can see if we use them, they are quite difficult to use, or complicated to use. For instance, if you are trying to find the eigenvalue of a matrix, what we need to do is first, before this, we have to input the matrix, and then calling this command, and then return the eigenvalue of the matrix to the user. So they have to write a function code or the code in other languages. It may take about 10 commands or more to get the result. So it might be quite complicated. If one of the commands is misused, then the result is unreliable. So this is a case where Matlab began to merge. The developer, or the co-developer of AcePack and LinPack, Professor Clark Moller, when he taught the courses in linear algebra, and he expected students to use the packages to solve certain problems, he found that they are too complicated to use. So he suggested a new way of solving this kind of thing. What he suggests is to write a computer program to accept in an easy way a matrix, and then use this kind of command to replace all the other commands to find an eigenvalue or measure. And this is the beginning of Matlab. So Matlab takes its name Matlab, this laboratory. It was originally a matrix laboratory for solving linear algebra problems, and now it began to be developed and get stronger and stronger, so that it becomes the standard language in scientific and engineering fields. And it is the top computer language in many fields, such as control and other disciplines.